Would not be cool at all. So welcome. Hello. Happy Sunday. 4th of July weekend is over. And it's back to work.
Everybody knows that relational databases don't scale because they use join.
Thank you for that resub.
Join.
That
join,
tier 1 resub 2-month
right
streak, baby. Thank you so much. Appreciate that. So, is big data getting too big? I think the answer might be yes. I'm not sure though. All right, so here's what we're gonna do today. Oh crap, my thing is, that's not a good look. You don't want that to happen. So here's what we're gonna do today. Okay, so this gcassert thing I did last time. It's a utility that lets you, if you want, make a Go program that has functions that you are asserting are inlined by the compiler. All right, so for example, here's a test case. This function is inlineable because it's just really simple and silly. It doesn't have anything. The compiler can always inline this thing. And if you write gcassert inline and then run this gcassert tool on this program, then it's going to tell you, well, it's not going to tell you anything. But if you tried to assert that something that wasn't inlineable was inlined, then it's going to complain. And that's the point of this tool. It's to help you not have to get extremely confused about when things are being inlined and when they're not. So I'll show you a quick example just to get back into the swing of things. So let me just make sure that this thing is up to date. Go build command. And how is everybody? I hope you're all doing really good. I hope you're really doing fantastic. So if I hit gcassert test data like this, what it's gonna do is it's gonna run, it's gonna check all those assertions, right? A not inlineable function that I've marked as inlineable is going to complain. The call was not inlined. Bad boy, you know, bad boy. Likewise for this thing, likewise for this thing, and we also did it for bounds checks. So I think what I wanted to do though, because this is a little bit irritating that you're always having to put this gcassert inline line next to the call side of the thing that you're asserting is inlined. What I want to do is make sure that you can also add a gcassert inline here. And what this is going to do is going to say that every time that we call this function in the package, it's going to make sure that that call is in fact inlined. So I don't think it's going to be that hard, but I want to do it because it's really irritating to have to put this in all the spots. So here's how it's going to work. Here's how it's going to work. Essentially, we need to edit this big fat parse loopy thing. And we need to add the ability to notice when not just a call site is being inlined, but also a function definition. So I don't really remember how this code works, but we'll figure out. Essentially, it looks like we've got a visitor. This music is too loud. Too loud. Turn it down. Turn down that music. Goodbye. It's a little bit less loud. I feel like I'm just distracting myself listening to this epic jam. All right. All right. So we've got this visitor, right? Here's what the visitor does. It goes to look at the AST of the Go code. I think this node probably we pass in a file at first. If it's nil, we quit. We look at some comment maps. I didn't really comment this code at all, huh? Oh, a comment map. That's something from the Go AST library. A comment map maps an AST node to a list of comment groups associated with it. Okay, so this is how we pay attention to all of the GC assertions that we've added. And GC stands for Go compiler. Because that's what, I don't know why they call it that, but they do. Okay, so, all right. Let's make this happen. We associate comments with each of the line numbers, something like that. It looks like what the heck is going on here? For each of the comments, we figure out what AST node is associated with it, and then we add a little bit of information in this map that says that this particular line number has a directive. So I think that makes perfect sense enough. And I guess there must be some other part of this code that then looks again, right? To try to search. Okay, so here we have for each of the lines in our directive map. No, this is for parsing the compiler output. Oh my God, I haven't even looked at this code, you guys. Okay, first find all the lines of code annotated with gcassert directives. What the heck is actually happening here? Okay. I think what's going on is that we don't actually ever have to truly care about what's inside of this AST because we're really relying on the Go compiler's output to have the line numbers, and we're just sort of checking. We're just searching for these line numbers. We never really care about the structure of the AST, and that might have to change. I want to say that might have to change, but yeah, I don't know, honestly. I don't know. Okay, so let's actually just do a quick test here. If I said go tool compile, and then pass in this fatty thing here. Let's see, go tool compile / test data / ... No. Star.go. Okay, and then I pass in all of these extra debug flags like, oh, you know what we should really do is go build. We can do go build. Go tool compile is a little bit lower level. It's not necessary. So we'll say go build -d -m test data. Yo, and Sileki, what up? Happy 4th to you too, my friend. I hope you're doing super well. I'm just struggling to remember even like what my life is about right now is kind of how I'm feeling. Go help build. It's like I left this project, I went away for the weekend, I got back, and then all of my knowledge just evaporated from my head. All right, okay, so we have to pass in GC flags to get this special information. GC flags equals -m / test data. There we go. Okay, so here's the thing. What we really want to do is we need to capture this little thing here. We want to capture the name of the function that's getting inlined or not. And then we want to go and remember for each function that is annotated with inline. And you know, maybe we need a different annotation for this, to be honest, because it is a bit of a different use case. It's sort of like a must inline all call sites. Well, I think we'll reuse it. We'll reuse the gcassert inline thing for that. But essentially we need to match on this. And then we need to, yeah. When we detect a gcassert inline annotation, that's on a function. We've got to write down the name of that function and then match it later. That's essentially the plan. So let's see if we can make that happen. I'm not really sure if we can, but we'll do our best. So when we run this guy, this is kind of the thing that I'm confused about. It's like we don't even inspect the type of the node right now. And I feel like we need to. Yeah, so we sort of need to say like switch node dot type, oops, case, and then I think this is like a func decal. So a func decal, if we look at our test case, I guess we should probably make a new test case for this, which is going to be like func always inlined, and we can just have reuse the same function body because we don't really care. And so this is going to have a gcassert inline annotation on it, which says that this assertion makes sure that every call site to always inlined is in fact inlined. And I guess what we really want to do in our test is probably make several, like we can sort of call always inlined like this, but then we probably want to induce a case in which always inlined is not inlined, which will be an interesting experiment because, to be honest, it's always a bit difficult for me to predict when the compiler is going to inline something or not. It's sort of like you need to have an extremely complex and long function that makes sure that it happens. And I'm not really sure. I mean, that'll be sort of an interesting experiment when we get there. It might just mean that we need to say like func giant function and then call it like a million times or something, because I know that there's like a cost function that it uses. So we'd sort of just say like some int, and then we would just basically say sum plus equals always inlined of sum, and then just like copy paste this a million times, like literally copy and paste it a million times. And I think that this might confuse the compiler and say, oh, I shouldn't inline this because like the cost is too high or something like that. I don't really know. This is just pure speculation on my part, to be honest, but it'll be sort of funny. So then I'll just return sum and we can see what happens from here. Actually, before we go any further, why don't we just run the compiler on this to see if it does in fact inline all of these or not. It kind of seems like it does. Yeah. What if we pasted it like a really shit ton of times? Like just like a gajillion times, right? I think eventually, well, first, if it doesn't kill my IDE, I think eventually this thing is going to make the compiler not inline it. Well, that's my hope anyway. See what happens with this one. Okay, every single call is still inlined. Okay, we might need to get a little bit fancier and actually figure out what this heuristic is, because I'm just not too sure whether it's gonna work otherwise. So let's actually just, well, I bet it's inlining in the same way that a plus equals 2, a plus equals 4 will go to a plus equals 6. You think so? We can find out. I mean, we can, if we say, if we dump this assembly, then we can find out. So I guess I was expecting to see, a lot of, yeah, you're totally right. I didn't know the compiler was that smart. Okay, so I wonder how we can trick it. Any ideas about how we can trick it? Maybe put some if statements in there or something like that. If I add a single for loop, it's gonna get rid of, it won't be able to inline it. What if I said, what if I just doubled it? Is it, what's it gonna do at that point? So it claims to still always be inlining everything. Try a non-inlined call using the value in between each. That's tricky. I like that idea. Okay. So let's see. So then I can say sum plus equals not inlineable. Okay, let's just ditch all this stuff. Not inlineable. Yo, Sartak, what's up? How's it going? We're trying to trick the compiler to not inline some stuff so that we can then make sure that we're proving that it is inlining things in other circumstances. And it's not that easy. Okay. Let's just copy and paste this thing like a million times too. Okay. All right, this is gonna be good. This is gonna be good. We'll see what happens. What does the compiler do with this baby? Okay, so it has a bunch of calls to not inlineable, which is great. Hold on, let's stop dumping all the assembly. Let's just see what it says in the debug output. What is that emoji? The Rudd coffee grounds. Inlining call to always inlined. Frustrating, huh? There's got to be a better way. I mean, I don't know. We're just trying to convince the compiler to do something that it doesn't want to do, right? Yeah. Okay, let's try to yeah. Let's think a little bit more logically, huh? So I know that the compiler will not inline things with for loops, but I do think that the compiler will inline things inside of for loops, so that's not really a thing that I could try. Make the address for the function seem dynamic. Yeah, that's a good call. That's a very good call. Very, very good call. Okay, so I'll say var f func, and it's going to be a func int. And then I'll say if true, or I'll say if b f is equal to always inlined. Very smart, very smart. Otherwise, I'll say f is equal to not inlineable. And then I'll say f of b, or f of, let's see, return f of I. I don't know if this is gonna quite work either. Well, let's find out. Yeah, the problem is that it doesn't actually even see that there's a call to it at all now. Like I need it to know. I need it to be a literal. I need it to definitely say like always inlined of something, or else I don't think that this is gonna really work at all. The thing that confused it last time was like an enormous switch statement. So I wonder if that could do it. What about this? We got a Vim macro going, baby. All right. Hands free. Okay, so what if I then say return always inlined of I? Is this even gonna work, or is it just gonna sort of know? Dude, this is so lame. Oh man, not inlineable. Okay, what does it do in this case? Let's just see. Grr. I don't know, maybe whatever. Maybe it's just too hard to find a test case. I mean, I can use as a test case my actual program that has this situation come up. But I don't know. Oh yeah, I could just disable the inliner. That's a good point. But then it's gonna be a little bit awkward for me to run my test case. Yo, Jason, what's up? How you doing? Hope you had a good weekend. We are attempting to fool the compiler and having a hard time doing it. Go no inline. Yeah, but I think that's a good point that we could use that, but I think that is actually on function definitions, not function bodies. And I see what you're saying. Yeah, that's a fair point. I could just say gcassert inline, and then then I could say go no inline. And then I think that maybe, yeah, that's a very fair point. Very fair point. We can just get rid of this whole nonsense. And then our sum plus equals always inlined should never be inlined, even though we expect it to. All right, so that's gonna work out. Good call, man. Thank you for that suggestion. So we should see, yeah, we don't see a call. We don't see a thing that says inline and call to always inlineable. So I think that's a good enough test case probably, which means that all we need to do is actually write the code, which is harder. That's fine. Okay, so essentially what it's gonna be is like, we'll put this down here, and we'll say if directive is equal to our inline directive, then we check to see whether it's a funcdecal or some other thing. If we see go or gcassert inline on a func decal, the user is instructing us to assert that every call site of this func decal is being inlined. So what we'll need to do is probably make another map. Right now we have this directive map, which contains a map from int to line info. Does that make any sense? Oh, I see. So it contains a map from the line number. I'll just write this down because I don't know why I didn't comment this before. Directive map is a map from line number in the source file to what? To the AST node, the directives that it found, as well as some other stuff. So from line number in the source file to the AST node that the line number corresponded to, as well as any directives that we parsed. Okay, so I guess the idea is really that we need another map, to be honest. It's not enough to just have this. We need to have a inlined func decal map sort of thing. So I don't know if that makes sense, but inline func decal map is going to be a map from string, which is going to be the is a map from the name of a function that was marked with gcassert inline to what? I mean, really, it's just a set. We actually don't really care. We actually really don't care.
Computer's hooked into over 1,000 data banks throughout the world.
Mapped to anything. Yo, Jacob not running. Thank you so much for the follow. Yeah, I don't know. I mean, I think we do want it to be a map to something, but I just don't know what it is yet. So we'll just make it a map to empty struct. Wait, like that. Okay. Cool. So back down here, we'll basically say, actually, we want to capture this thing as well. So we'll say n.name. This is going to be our map. Now, I think it will be probably a little bit more tricky because this thing could be a method and not just an ordinary function, in which case I don't quite know what's going to happen, but let's just assume that these are just ordinary functions for now. And in fact, maybe we can just print out a helpful message if it has a receiver, because we don't want to deal with that just yet. Although I suppose there's nothing preventing us from doing that. It's just like we don't really know what the format's going to be. Actually, why don't we quickly add a test case for that? So we're going to say func, we'll say type test is an int, and then we're going to say func t test inlineable method. And this is just going to return 0 or something like this. It's going to return an int. So this is going to then have gcassert inline, and the idea would be that down here we can say sum plus equals, like, I don't know. So what is test again? Test is an int. Test of one dot inlineable method, and then this should definitely be inlineable. I guess what we should really do is have two of these. We're going to have an inlineable method that isn't marked with the assertion, and then as well as an always inline method that is marked with the assertion. So the point is that people can do it both ways if they feel like it. Okay, so this one is going to be marked with gcassert inline. Maybe this one, yeah. And then this one's going to be marked with the always, what is it? Always inline method. But not have the declaration. And then we also probably need one that isn't inlineable that will fail, just to make sure that the failure case works as well. Never inlined method. And this is going to say for I in range. We'll just say for I is equal to 0, I is less than, I guess I'll pass in an int. I plus. I can't have them both be called I. That would not work. I is less than n. I plus plus. We'll just do a sum again. Sum plus equals I, return sum. Okay, all right. And then down here, we're gonna do never inline method, pass in some arbitrary thing, and then we'll just say gcassert inline, and this should fail. Okay. So now let's just examine what the actual output here looks like. So it says inlining call to test dot. It actually just includes the dot, which I guess makes sense. The type plus a dot plus the name of the method. Okay, well, I guess in that case, we can deal with ones with receivers pretty easily. So we can just do that then. And the way to assemble the name is you just add a dot in between the receiver or the type and the function name, which is basically what as you'd expect, but I just didn't know. Anyway, okay, so let's see. We'll say name is equal to fmt.sprintf ss, whoops. And I guess the first one is going to be optional. We'll say var receiver string, and then I'll say if n dot type dot, no, n dot receiver is what it is not equal to nil. Receiver methods or nil functions. Not exactly sure why this would have more than one thing. Oh yeah, we can use our AST Explorer for this. It's a handy tip. ASTExplorer.net. So we can use Go, and we'll say type, well, we don't even need that. We'll just say func a receiver, blah, like this. And we just want to figure out what does this actually look like in its receiver. So it's got a field list and a list of one element. And in the case of something that doesn't have a receiver, receiver is just nil. Okay. Oh wait, is it? Type. Yeah, okay, receiver is just nil. I don't know why it's a list. I guess it doesn't really matter. Okay, so if receiver is not equal to nil, then we say receiver is equal to n dot receiver of 0, I guess, dot list of 0 dot more than one name too. I don't know. It's just so confusing. I just feel like they reused some types here in a way that just doesn't make a lot of sense. It's like the 0th. All right, we're not even looking at names. We're looking at type. So the type dot name. What is type? It's just an expr. Oh man, that's annoying for sure. I think we can always cast it to an ident though, because I think that you can only have an ident in this particular context of the function receiver. All right. And then I think we want to add a dot to this because we sort of need one of those to assemble the full method name. And then the second thing that we want is the func name, and that's going to be node or n dot type dot, no, it's just going to be n dot name, right? Let's look at the Explorer. The Explorer says blah is the name. Okay, and then over here we can sprintf with our receiver and our func name. Okay, so this is going to be the name that we're going to be searching for. And so for now, what we're going to do is just going to stash it into this map inside of assert visitor. And we need to probably create that, or else it'll complain that we haven't done so. So we'll say make from a map from string to struct for now. Okay, and then we're just gonna say v dot inline funcdecal map of name is equal to struct empty struct. Okay, cool. So that is all good. And then the point is that later on, when we're actually matching these output messages, we need to search for situations in which we're not inlining the function, which is actually unfortunately a bit tricky because, well, that output log doesn't actually tell us all the places that the function is called. So it sort of seems like we need to just search for it in our AST walker, which is a bit of a new responsibility for this AST walker, but I suppose that's fine. It's a little bit unfortunate, I'm not gonna lie, but I guess I'll just deal with it, huh? So we'll say search for all func call sites and write down their line numbers so that later when we are parsing the Go compiler's output, we can find call sites of inline functions, of function decals that were marked with gcassert inline that did not receive an inlined message from the compiler. It's a bit of a mouthful, but I think it's basically correct. So we'll say switch node dot type, and we'll say, I guess we want to search for, what are these? Can't remember the name of the, it's a call expr. All right, so we're just gonna search for ast.callexpr. Guess this needs to be a star. And we need to say, I mean, to be honest, we kind of want to do a second pass over the AST because the first pass is the one where we find all of the things that are marked with the inline. It's sort of either we store every call expr in the whole AST and then match it later, or we do 2 passes. I think I'll choose to do 2 passes because it keeps these visitors a bit cleaner. Yeah. I don't know. I mean, it's kind of messy. I feel like this code also needs a bit of a refactor, to be perfectly honest. It's not that great. There's also something that I'm slightly nervous about, which is that I'm realizing that this directive map doesn't seem to be scoped per file, which is a little bit disturbing. Unless we... Oh no, I see. So we keep a map of maps. Okay, so it's all good. It's all good. I think what I'll do is that I'll just keep a big map of all the call sites. How about that? No, I really want a map of just the call sites that were for functions that were marked as inline. Okay, so I'll just do a second pass. I'm just gonna suck it up. I don't love it, but I'm just gonna suck it up. Okay, so we're gonna have another visitor called the type inlined. It'll be like the must be inlined caller visitor. Must be inlined caller visitor, searches through an AST. Searching, I guess it's sort of gonna be like finding all call sites of ooh, you know, this is gonna be tricky too because of the whole thing about the method thing that I was mentioning earlier. It's sort of, you can't just do a simple search. You kind of have to have type checked everything, which is not gonna happen in this tool. So I'm sort of tempted to say that you're not gonna be able to do it with methods and just with raw functions. Because otherwise I'll have to really, because you won't know whether any particular call to a method is part of one of the types that you cared about in the first place. So I might just give up on that dream. Yeah, I think I'll just give up on that dream. And there's also sort of another problem, which is that you sort of need to have package information, don't you? Because it's totally possible that somebody's going to be passing in functions from other packages. So I kind of also need to be paying attention to packages. And that's also a big pain because a package could be named the same thing as something else, like a variable. So this is actually a huge pain in the butt. And it sort of also needs the type checker. Yeah, I don't quite know what to do about this. I mean, maybe I'll just kind of forge ahead and not worry too much about that, even though that I know it's a real problem. Whatever, I'll just do it. Okay, so finding all call sites of any of the passed in func decals and marking down the line numbers at which they're called. Basically something like that, right? Now the other option is that it could actually edit the directive map that the original visitor gives you, which could be kind of cool. I kind of like that, to be honest, because then it would sort of be saying, yeah, just sort of unifying the fact that somebody else is going to be parsing this directive map later. I do like that. Okay, so into the provided directive map. Okay, so essentially we're going to have a directive map that's going to have been passed in by the earlier visitor. And then we're also going to have a, yeah, it's really the same old, it's these very same two methods here, or the same two members here. It's just we're sort of going to be using them in different ways. So that's, you know, it's nice enough, I suppose. Okay, so then to implement this visitor, we will have this visit method, and we're going to say switch node dot type. Whoops, that is not how we do. I always want to put a colon instead of a brace as the first thing after a switch, and I always just get that wrong. I don't know why. So okay, so we're going to say case ast.callExpr. And then here we essentially say, try to match the call expr with a func decal that had previously been marked as a must inline. Marked, I guess I'll just say marked with gcassert inline. So we'll say if n dot. Yeah, so I'm actually just going to get rid of this whole receiver business because I'm just not going to be able to do it right. So if I'll say if n.receiver is not equal to nil, I'll just, I guess I'll kind of just print something to standard error, maybe. Fprint f os.standard error can't mark or what is this called? It's like functions with receivers. I'll just say can't mark methods with gcassert inline, and I'll just do nothing. I kind of actually need to just break out of this entire. I'm too many breaks in, you know. I gotta leave this, and then I've also gotta leave this. So I guess I sort of need a directive loop label. I hate doing this stuff, but it's just probably like a sign that I'm not doing enough functions, but what are you gonna do? Continue directive loop. All right. I can get rid of this whole thing. I can just say inline func decal map of func name. I can even inline func name. What the heck? Okay. Okay, that's a bit simpler. Cool. All right, so the next thing that we're gonna do is to be searching. So we'll say if n.receiver, n does not have a receiver, n.fun. Oh yeah, this thing doesn't have any idea about receivers or not. So I guess we literally just have to match based on the function name, which is gonna give us false positives just like 100%, you know? I almost feel like this just isn't gonna work, because somebody could just make a function with the same name as something that we've defined and then call it, and then this thing would fail, you know? So I just feel like this is actually just not gonna work, and I might just need to hang up this idea. You know, as an example, in our test, I could easily just say, always inline is equal to, and then make a new func, and then call always inline like this, and then my thing would think that it's the same call site, and if it failed, it's gonna be a false positive. So this is just busted, dudes. Just fully busted. Now, there is this way to actually have the type checker run and stuff like that. I suppose I could investigate that. I think the way that works is that this thing that we invoke, where is it? Where we say packages.load. I think you can pass packages.load some more and cooler options. Like you can say, right now I'm passing in need name, need files, need syntax. But I think you can tell it to give me types, stuff like that. And I've never used this, but maybe this would be like the time to do it. I'm not really sure even how it works. But just out of curiosity, what does this package thing have to do with types, you know? That's the question. It gives us back these... It gives us back syntax, and that's what we've been iterating over, but it also gives us back this thing called types. Types provides type information for the package. So what is all this, huh? It gives us a scope. A scope maintains a set of objects and links to its containing parent and contained scopes. Objects may be inserted and looked up by name. Okay. And that doesn't really tell me all that much. Lookup returns the object in scope as with a given name if such an object exists. Okay, and what is an object exactly? Whew. I mean, I feel like this does actually have all the information, right? It gives me back a package, which would tell me, you know, whether or not this thing was part of the package, which was what I was complaining about earlier. And it gives me something called a type, which I wonder I could probably compare somehow. I feel like I need to read a tutorial on this because I think it's kind of advanced stuff. Sets the object color? That must be some internal implementation stuff. Dude, I'm too tired for this though. I don't want to do this. Maybe I'll do it another time. The underlying type of a type. I mean, I just would surely be to get it wrong. There's just no way that I would get it right in the beginning, and there'd be a long debugging session and da-da-da-da-da, and on and on and on. But the truth is that the alternative is just failure. Because I don't think that I can actually possibly make this strategy work at all. So I guess, I don't know. What if I just had a look? What if I just had a look? You see where we say packages.load, right? That's where I could ask for packages.need, packages.need types, right? Like, what would this do, you know? It has types, fset, and ill typed. Types info? What is types info? It provides information about the package's syntax trees. Maybe this is a simpler thing. This looks better. Info holds result type information for a type check package. And it gives me a map from expert to type and value. That's actually good. This looks like it's actually a lot simpler to use than that other thing I was looking at with the scopes. That seems scary and unfun. Defs maps identifiers to the objects they define. Uses maps identifiers to the objects they denote. What does that even mean, though? Implicits, selections, scopes. Oh, this is how I get to a scope. Interesting. I feel like I want this stuff, but again, I also don't think, I'm too scared. I'm too scared to do it. What is a type and value? A type and value has, oh, it's got a value just for constants. I think I might, I don't know. Okay, what if I just said need types info? I don't. Okay, so let's see. Let's say I decided to go down this rabbit hole, right? What would I do? Basically, I would say, for every call expr, I would look up into this type map. And I would match, oh, you know, I think it might be possible. Because essentially, what I would want to do is keep a map of the types of the func decals that had the must inline information. Okay, we're just gonna try it. I'm a little bit nervous, but we're just gonna try it. So we're gonna ask for needs types info. And then up here where we're gonna save just that line number, whatever it was that we were doing, right? Where we're saving this map from string func decal name to struct, I think what we'll actually want to do is save a map, or maybe just a list. It probably just has to be a list because I don't think that you can hash these interface types. So we'll kind of just, so we'll say inline func types, right? And we're gonna actually make a slice of types.type. Something like that. Because I don't think that a type name is unique enough, you know what I mean? But I think that, yeah, truth is I just don't know whether you can compare these things, right? I mean, I know that they, yeah, I don't know. Like, would it allow you to compare them by pointer? Like, does the API guarantee that two types of the same type are the very same object? I don't really know. So I don't really understand all this. Suppose you do the substitution and it's incorrect. Will the error message that the user sees be that bad? The thing that I'm nervous about is just that, like, if somebody had a program in which there was a name conflict, which could happen for any number of reasonably good reasons, it would be, the program would say you did not inline, you know, XYZ thing did not get inlined, even though we actually don't care whether that thing got inlined or not because it's just of a completely different object, if that makes sense. I suppose, yeah, I don't know. I mean, like, you could just have it sort of be hacky, but it makes me a little bit sad. Because it's just, you know, it'll be so transparent that it's literally just matching by name. In other words, like, if I had this, yeah, actually, now, now that you mentioned that, I'm not sure if my approach will even work either, right? Because I could say, like, I want to assert that func always inlined is always going to get inlined. But then down here, I could say, you know, always inlined. I could shadow it, essentially, is the point, right? I could say always inlined is equal to func a int return a times a. And then down here, if somebody called always inlined of 3, and let's say this didn't get inlined, right? So let's say it was a loop for I is equal to 0, I less than a, I plus plus, whatever. I don't know what it's gonna be. Then this thing would not be marked as inlined, and it would sort of give me a false positive. It would say this thing did not get inlined and it should have been, but really I was annotating this always inline, not this always inlined. And I think that could be a point of confusion, but maybe it's, I don't know, maybe it's just such a minor thing that I shouldn't even care. Yeah. The other thing is that, like, now that I actually think about it, the use case that I really care about is one of these method cases. So I kind of need that to work. Ay. But I think I just don't really know how this like type map business works. Like, for example, if I had down here when I have test of 0, like, can I ask for the type of just this thing? I really have no clue. I'm kind of interested to find out, though. Let's actually just scratch these changes. And I just want to run... Well, no, let's not scratch these changes. I just want to run this type checker thing, because I've never used it, and I'm very curious to see what it does. Types.type. Oh, we don't need to do this. This is going to be a slice of types.type. I mean, even this is sort of unnecessary. I don't know. We don't need any of this crap. I just want to see what happens when we try to type check these test files. Yo, bro, Hanster, what's up? Late night data banking, exactly. This stream is going. It's acting a little. It's a little awkward. Not gonna lie, because this idea is not really working out as easily as I thought it was gonna be. The idea is we're trying to add this capability to mark a method or function as always inlined, and then check for all the call sites whether it got inlined or not. But the thing is, I'm struggling because if you just match by name, it doesn't really work. You have to sort of match by type and name or something, and I don't know. So, okay, here's the thing we're gonna do. We're going to run this loader with the type checker enabled and see what it does. That's kind of what we're at. Packages.load. So we're just gonna break here, and we're gonna see what it looks like. I've never even used this type checker, and it's kind of cool that it exists, you know? So let's kind of take a look. We have one package, we have syntax, and we have a nil types info. What's the deal with that? Why do we have a nil types info? I was told that there would be types and types info. Wait, how is this useful if I don't get a types info though? Wait. It is set only when syntax is set, okay. Wait, this is BS. Do I also need, maybe I also need types. All right, so I've got packages, I've got types, and I've got types info. Okay, so I think I just needed to tell it to ask for both types and type info. Then inside of this thing, I have this giant map from AST expert to type information, which is pretty cool, to be honest. It's actually extremely cool. And so the question, okay, here's the question. The question is, for my example here, always inline method, is there a type of this thing that then I can associate back to the receiver of the function here that I've asserted, or that I've added gcassert inline to? If so, that would actually be pretty sick. And so how do we search for that? I don't know. It might be sort of impossible. I might need to do this a little bit more programmatically. Otherwise, I'll just be searching through this huge list and it'll be gross. Here's a call expr. I mean, this is silly. This is fmt.s.printf or something like that. So I suppose I could sort of look. That looks like it's in the other file. I don't know. Okay, whatever. We'll just do it. We'll just do it the cool way, which is the programming way. All right, so here's what we're gonna do. We're gonna say in our walker, when we see a funcdecal here, we're gonna check out its type. So we're gonna say v dot, now I need to actually pass in the types now too, don't I? So I need to say type info or whatever. Is the problem you're running into that you have to match the base object type when the function is a method on an object? Yeah, exactly. Or just the function type in general. Yo, W. Roberson, thank you so much for the follow. Does your use case have to worry about whether the receiver might be an interface rather than a concrete type? It does not. That would be really problematic. I mean, then I would have to like look at a type hierarchy or something. That would really be trouble. That would be big trouble. No. It is definitely relevant. It is definitely relevant. And I luckily just think in my particular case, I don't have to care. Can interface methods get inline? That's a great point. Maybe not. I don't know. All right, so I need to get, I guess I just need this thing called types.info. Types.info. Okay. And when I make one of these, I'm gonna have to pass in, at this point I might as well just pass in the whole package, right? No, I guess not. No, I'll just pass in the whole package, whatever. Okay, so this is gonna take a packages.package. Guess I'll have to call it P, because package is a keyword. All right, don't need this. Okay, so cool. Unless you know statically what the type is, you don't know what to inline. Yeah, yo, good point. All right, so if we hit, so if the receiver is not equal to nil, fetch the receiver's type. So we'll say v dot package dot types info dot types of, oh God, come back, n dot receiver. It's a field list, dude. It has to be an expr. What? Video frozen? I don't know. My stats say everything's good, but my internet has been acting terribly, so it might not be just you. I'm not sure. Wait a minute. It was just you. The type map does not record the type of every identifier. Ooh, defs. Okay, defs maps identifiers to the objects they define. That doesn't sound right. Uses maps identifiers to the objects they denote. What the heck does this even mean? I need like a tutorial on this types info thing, honestly. Packages load types. Types info. Types tutorial. So what would this is this like uses map, essentially, is what I want to be looking for. Or is it uses? Uses. You don't know why there isn't just a call sites method on the function definition? Dude, what if there was? No, there isn't though. That's how LLVM is set up? That sounds way better. Identifiers to the objects they define. What is an object? Oh, I think this actually might be right? Because look, I think what we need to do is pass in the name of the struct that the receiver is on into this defs thing. Let's try that out. Okay, so we'll say v.p dot types info dot defs of n dot receiver dot list of 0 dot type. No, it's names of 0. Right? It's a map from AST ident, which I thought that this was. No? Yeah, it is. All right, so receiver type is equal to this. No, this is actually the receiver, and then the receiver type would be receiver dot type. Quite a mouthful, huh? Yeah, again, it's just like, I don't know why they have these excess, like they have the not as specific AST nodes as they could for these situations, because you can always zero index into these. I don't know why they wouldn't just, it doesn't make that much sense to me why they wouldn't just give it an ident or something like that instead, but whatever. Okay, so then inside of here, what we need to do is get rid of this stuff, first of all. And we need to put into a map, like, I guess I don't quite know, like, the name, like the object that we actually need to be caring about. Like, what we really need to be caring about is sort of an abstract essence of this function, right? Then I wouldn't have to deal with this receiver's type or anything. And I wonder, like, is there a way to get sort of this essence? Because type isn't right? If it was just type, then it's like, you could have any old function with that same type and it would be the same. It's essence. I mean, maybe this object thing is
computers hooked into over 1,000 data
Yo,
banks.
Getsu, thanks for the follow. Computes the relationships between identifiers and objects. I mean, I don't know. What even is an object in this case? Well, let's just try it out. Let's just try it out. So really what we want to do is map a pair of receiver type and function name, right? That's what it comes down to. Receiver type and function name. And this thing is a type. Type is an interface, right? We were looking at this already. I don't know, man. It's gross. I don't like this. I don't like this at all, to be honest. All right, well, we'll make a little another type for this. We'll say type func. I mean, I wish I knew. There's got to be like a way to uniquely reference a particular function, right? That's the whole point. Hey, Getsu, editor and debugger. This is Golang, so it's the JetBrains Go IDE. And the debugger is Delve. There's actually a bunch of this. There's this thing called Go Analysis, right? Golang. There's like this whole set of packages that people are using these days to do this stuff, right? So I kind of wonder whether I could look at some examples of this. That would be a little bit helpful for me. Make this a bit bigger. In fact, I'm pretty sure that there are some examples of this in the cockroach source code. So maybe if I just check out that analysis, maybe I could get lucky and maybe somebody will have done something similar to this already. Because I just have to learn how the APIs work, to be honest. Problem is I don't actually know whether any of these have to do with functions. Assign.go, what is this one? Check for useless assignments, that doesn't sound right. Let's see, so go function usage linter or something like that. The copy lock? What is that? Copy lock. All uses of this struct. Inadvertently check for locks erroneously passed by value. Checking whether its receiver parameters or return values are locks. So what it does is it looks at the type of the field and
data
yo, Alex Martin G, thank you for the follow. Let me open this in copylock.go. Okay. What is this doing? Detects lock, copy, and return statement, right? So for each of the results of a return statement, and these things are just regular exprs, it says if path is equal to lock path RHS, what is that? Okay, so for each of the things, is it a composite lid? I don't care. Is it a call expr? I don't care. Is it a star expr? I don't care. Lock path returns a type path describing the location of a lock value contained in type. If there is no contained lock, it returns nil. But where is it? Types.implements. Yo. This is complicated. I feel like this is too complicated, and I'm just implements returns whether type V implements interface T. And locker type is probably just set to, excuse me? Oh, I see. We define it down here as saying it's either, oh man, you inline define the interface. You say it is a thing that has both a lock and an unlock function on it. I don't know, man. This is, it's a little different. I feel like this is just not the thing I can really pull out right now. I don't know. I feel demoralized. I feel really demoralized by this problem. It's too difficult. It's really I mean, it's not checking for a type, right? It's really, we need to be checking that it. Yeah, like what is the information that the compiler figures out, right? Like if it sees a call to always inlined, it knows more than just the type of this function. It also knows, in the case where we don't have this like fake out shadow guy, it's got to know that we're actually specifically referring to this function here. It has to know that, obviously. And so the question is that information in this types info thing, or does it come in a later stage of the analysis? That is sort of the ultimate question. So maybe if I look at this thing, object, which really could be anything, the question is, besides just the type, which is not enough, does it have anything else? You know, it doesn't really seem to. Like, hold on. Where was that types info thing again? Types info. It maps expressions to their types, and for constant expressions, their values. For possibly parenthesized identifiers denoting built-ins, okay, not relevant. It maps identifiers to the objects they define. This seems like what we want. This seems like what we want. Like perhaps this object thing is actually comparable, right? If this object thing was actually comparable, objects they define. Nah, this isn't right either because it's just not enough information. It's just a single ident. It doesn't also have like a package clause and stuff like that. So denoted object or nil. Yeah, you can't type check the function without. I just like don't understand how to use this thing, honestly. So I guess we could go back to look at our debugger, right? Let's run this thing again. Oh God. I broke everything. Oh, right. What happened is that I have a pointless thing here, and this thing needs to, what's the matter with this? This needs to have an address of, oh, other way around. This thing's gotta be a pointer type. This thing's gotta be a pointer type. Okay. All right. So like what's in defs? That's the first question. What does defs have? Here's a def with inlineable. Okay. So let's go look at our test case here. Inlineable is a def with a name that points to an object. And the object is presumably the thing that I could compare against, hopefully. And then hopefully maybe we could have somewhere down below yeah, the thing that I just don't get is that like oh, wait a minute. So theoretically, I think that even in my syntax tree, I actually might because I think didn't I see that somewhere an ident actually is connected. It has an object inside of it, and maybe if you like call the type checker, it's always going to be populated or something like that. So here's a call expr with format. Okay, I don't care about that. I have 2 decals in this, but I have so many. So this, whoa, name gcassert. What? So confused, so confused. Okay. Oh, the package name is gcassert. Okay, fine. How can I not have a stupid, like the name of the actual file in here? That's obnoxious, to be honest. Maybe it's number 1 then. I have 9 decals in this one. This seems a little bit more legit. I've got inlineable, not inlineable, test. Okay, I've got all sorts of crap. The first one, hopefully, okay, the first one's an import. The second one is this inlineable thing again. Yeah, I don't know what they do, man. I don't know. It does seem impossibly difficult to do anything. It's very frustrating. Okay, so inlineable, so 1, 2, 3, 4, 5, 6, 7, 8. So the 8th thing is this big fat guy. And the point is that, let's see, actually, let's go to the very last assign statement. Here's the left-hand side. Here's the ident. So sum. I want the right-hand side. I want the 0th. The selector expert, the call expert. The fun is test. The object. This is the key. What is this object? What is this? It's a type spec. Oh, I think this is actually good. I think actually the information is here and I'm just an idiot. Like every ident has an object associated with it. So all I have to do is compare the idents or the objects. So actually that makes things very easy. I don't know why that took me so long. Okay, so, okay. This is gonna be great. This is gonna be super great. So here's what we're gonna do. In our thing, what we need to do is when we see a func decal, do we have an ident here? Yes or no? Yes, we do. The ident is the receiver's, no, it's literally the name. And this object, this thing, add the object that this func decal's ident is connected to our map of must inline functions. Sheesh. Okay, once you learn that though, I mean, I'm still assuming that this is even true, which it may not be, but I suppose we'll just have to see. So we're gonna say, up here, we're gonna have a inline func objects. We'll just say inline funcs, must inline funcs. I don't know. So it's gonna be a map from types.object, which is a new thing for us, to struct. Okay, maybe we're getting somewhere. Maybe. So we're gonna say v dot must inline funcs of n dot name dot obj is equal to, all right, and this is gonna be a map from pointer of types.object struct. What's wrong with this? What is wrong with this, huh? There's nothing wrong with this. It's just complaining for no reason. Unhappiness? But why? Oh, it's an AST.object, not a types.object. Fool. How could I make such a silly mistake? Just kidding. It's not at all obvious. All right. Okay. So we've saved this into a map. We can just get rid of all this crap. And then, much later on, oh, dude, and this means we can do it in one pass too. This is the dream. This is the dream. This is the dream. I was thinking that we'd have to do it in 2 passes. It's totally pointless. What we can do is we can say, we can actually just add it to the directive map, which is quite nice. So we'll say switch node.type case call expr if v dot must inline funcs of n dot fun dot no if n dot fun is an ident, so you can't do it if it's like an inline or like a anonymous func or something. That's fine. So if n dot fun dot, let's see, so we'll say ident fun ident okay is equal to n dot fun dot ast dot ident. If not okay, just get the heck out of here. Otherwise we'll say if must inline funcs of fun ident dot obj. So if this is, whoops, come back. If this is the case, then we say v dot directive map of line number. We don't know what line number is yet, huh? We do know.
Computer's hooked into over 1,000 data
Yo,
banks throughout the world.
Polgovisk, thank you for the follow. So we can say v dot directive map of line number dot n is equal to n. Can't do that, right? You have to do this whole dance with this whole business. Then I can say line info dot directives equals append line info dot directives comma inline, right? Yeah, I think this is gonna work. All right, let's see what happens. See what happens. What's it gonna do? So we'll say go build. No, wrong thing. Then we can say gcassert test data and see what happens. Assignment to entry nil map. I forgot to make this map. Classic mistake. How could I have done this? Okay, so we'll say must inline funcs is equal to make map ast.object to struct. What the heck? Kind of crazy. Oh, it's because I put a comment. I mean a comma. All right. Yo, bro, Hanser, when's your next Valorant stream? I've been looking forward to that. All right, so what does it look like? Some stuff is messed up, but I think I know why. This doesn't make sense because we need to basically make sure that we're not checking for the call site inlining on methods, right? We've gotta fix that up first of all. Yeah, it's essentially in this particular case, then we just like bounce out of here. Like so. Try again. Okay, so that's better. We're not caring about this particular guy here. And then why are we complaining about this? I think that, so this makes sense actually, because this, we know that this can't be inlined. The trouble is actually that, well, what is the trouble? What we sort of need to do is make another, yeah, it's this always inlined guy. Let's get rid of all this crap. We should expect to see 2 complaints. Always inlined should not match, or should not be inlined because we've marked it as inlineable here. That's kind of the thing. But we don't, huh? We don't. So the question is why? And I think that what we can do for this is, yeah, we can run the test again and use the debugger. Let's first of all see if this ever fires, right? All right, so what do we have inside of our v.mustInline funcs? Nothing. Oh, I suppose I actually meant to break in here. So let's jump over to here. All right, so we do in fact see a call here, and the particular function that's marked as must inline is what? It's this always inlined method thing, which is in fact the first time that we see that. So that seems legit, I suppose. Ooh, but you know what's trouble though, is that the object is nil. So we were trying to add, I was sort of hoping that this would always be good, but it isn't. Why is that? That's trouble. I thought I had figured it out, but realistically I didn't. The issue is that there's an object for the receiver, but there is not an object for the name of the function, which I don't understand, huh? Denoted object or nil. So how am I supposed to get the denoted object for a method, right? So let's see if it works for the, I was gonna say let's see if it works for the function non-method, but the function that we marked as always inlined, but it didn't seem to stop there, which is a little bit confusing. Do you only stop here once? We only stop there once. Why is that though? Is it because we also have this? Huh? How though? And why? Is it like, is there just like a bug with other comments or something like that? Ooh, that is probably the case. There's a bug with other comments. I've got to fix that too then. Okay, so in this particular case, which is where we're using a raw function and not a method, then we have a func decal, which is always inlined. It has no receiver, and it does have an object. Interesting. So it sort of seems like in the case where we have a method, this particular thing does not get an object type for whatever reason, which again is just extremely obnoxious. Like why? Why is that a thing? Extreme frustration, dude. So another question though is why didn't this match really work, right? I don't know. I don't know why that didn't really work. Let's Try this again. Just to double doggy check. We'll double doggy check it doesn't work. So here's the method and the object is null. Obnoxious. Oh man, that's just so annoying. I don't know why that would be the case, but it is obnoxious for sure. The receiver has this type, right? And maybe inside of that, you're supposed to like, nah. Dude, that's so obnoxious. I don't get that. I don't get that. All right, okay. So we'll get to that part later. The first thing that I want to fix is just why didn't that regex match for this particular comment? So we'll quickly, we can just make a test with our little regex buddy, huh? Regex buddy, here we come. Regex tester, Golang. You love to see it. You absolutely love to see this. All right, so here's our regex, right? And I guess it wants me to escape it. In reality, I don't have to, right? Don't think I have to. Oh, it's because I'm in a weird like PHP zone? I don't need that. Get me out of PHP zone. Okay, so this is matching properly. And we're going to check this string, which I know does match. You love to see it. Exactly. So this clearly has a match. And what about this one? I would expect this to match too, huh? And it does. So why doesn't it match in real life though? Why doesn't it match in real life? Why? Why? So annoying. So annoying. Oh, I see the problem. The problem is that this continue is wrong. This has got to be over here. In which case I don't even need a label at all. Okay, I think that's going to fix that particular problem. Right? Let's return this to its original state. Rerun our debugger. And we hope to see 2 breaks. 1, 2. Okay, great. That probably makes no sense to anybody watching, but hey, what are you gonna do? Okay, so the second one is going to be the simple case where we don't have a method receiver, struct receiver, whatever. Still leaves me perplexed though. How am I supposed to get the object to which this thing corresponds? Okay, so here's a question. When I actually end up calling it, let's go back to our debugger and break down here. So we'll go over here. And we're going to be looking at the fun. So right now we're calling always inlined. Which I guess is probably up there somewhere. So I want to be continuing until I see something that says never inlined method, for example. I missed it or something. Or maybe a call expert is not really, I thought it was though. Let's actually just check in our AXT Explorer again. When I see something that says a dot blah, what does this actually look like in my... It is in fact a call expr, and its fun is a selector expr, which I suppose is this dot syntax, right? So I think I'm still allowed to be looking for call exprs. Seems legit, honestly. Okay, so let's... Oh, I see the problem. The problem is that I'm skipping... I need to be looking for expr statements that are call expr, or excuse me. I need to be looking for funs that are selector exprs and not just idents. Okay, so that's slightly helpful. So we'll say switch n.fun.type. If it's an ast.ident, then we know what to do. It's this. But if it's a ast.selector expr, then, you know, essentially it's anyone's guess. It's anyone's guess. And what we're gonna do to find out is just put a breakpoint here. So the cell in this case is the blah, and the X is the ident. So I guess, I don't even know, man. Guess I want to grab this. So it's like, instead of asserting that the fun is an ident at this point, I'm going to be asserting that the X is an ident, which is sort of the like first half of the selection expression, the selector expression. Selector. And then I'll just print out this selector, and then I can breakpoint here basically and try to figure out what's up, what's what. Get rid of this stuff. And we'll try again. Oh, I already did put a breakpoint there, good. Okay, so the thing that we are looking at this point is what? It's format.println. I don't care about that one. Don't care about that one. Okay. Apparently it did not quite find what I was looking for. Why? Why though? Are these things not in fact selector expressions? Let's break here. Maybe I've screwed up that little type switch. All right, so we'll look again. We'll get rid of this breakpoint. We're going to be looking for what n.x is. n.x is an ident, and it says format. n.x is an ident, and it says format. We're marking things as must inline. We're marking two things as must inline. Okay, we're back. And the x is another call expr? What does that mean? Oh yeah, it's because of this. Like, so I suppose that does make sense. I did, in fact, put this as a call expr. It was not at all. Oh man. But at least in this case, the object was properly set, right? So okay, so the object was properly set to be the type of this test thing. And the question was whether the cell, so in other words, the method that we're calling has an object. It does not have an object. So that's kind of like the missing piece, right? It's like we get the struct type that's got the methods on it, but we didn't get back the methods that were on the struct. Yo, it's so annoying. It's honestly so annoying. How are you supposed to live with that? It's like we were so close and now we're just so far again. So annoying. Okay, let's go back. Like, how could it not have that information? Uses? Uses maps identifiers to the objects they denote. Why doesn't it have like a nicely useful example here? Wouldn't that be helpful? This looks relevant. selections maps selector expressions, which is literally what we're talking about, I think anyway, to their corresponding selections. What's a selection? A selection describes a selector expression, xf. Oh, x.f, I see. I was confused. I thought it was talking like cf. Okay, so for the declarations, type t struct blah, type e struct blah, here's a method. Ooh, this is looking very hot, very relevant. Here's the selector. Its kind is a field val, I don't care. Its receiver is a type, which I'm also sad about because I was hoping that it was going to be an object. An object is the object denoted by x.f. Now this is looking useful. So this is kind of the dream, in a way. I think I can say, if I see a selector expert, I can say v dot p dot types info dot selections of n. Cell is equal to this thing. I guess I can say if cell is equal to nil, just get out of here. Then I can say cell dot obj. Is that right? Obj returns the objects denoted by x.f. A func in all other cases. Hell yeah. Now that's looking good. Okay, so then we just have to get back to where we've defined the method, right? Which we were having trouble figuring out before. But maybe now that we sort of know about this selections thing, it'll help us. Maybe. Init order implicits defs. I feel like it's gotta be defs in a way, right? We still have our debugger open, right? So inside of our v, inside of our p, inside of our types info, all of these things have a lot of information inside of them. So it's not like we can just sort of look through, huh? There's only a few selections. We know that these selections are probably good to go, right? So the first one is a call expert of a call expert, which is this whole test business. So that's good. That's the dream. And it maps to this inlineable method thing. Okay, so that's awesome. That is truly awesome. And the dream. Trouble is, where can we find inlineable method? Where can we find that? And where can we have written down its information, you know? It's got to be defs, right? Here we have never inline method. Here we have ints. What's that about? Ints. That's extremely confusing. Oh, maybe it's in the other file. That file was called what? bce.go? Ah, okay. So it's sort of out of order, but that's fine. I sort of just want to search until I find... Yeah, right? They're... I agree with you, man. It's taking me a lot of perseverance, and it hurts. But I feel like once you figure them out, it's actually pretty decent. It's more than just AST at this point. It's like all, you know, it's giving you quite a lot if you can figure out how to use it. So I want to search for something called never in, or maybe always inlined method. I'm sure there's a better way to do this, but I just don't care. Some not inlineable. See, what if we get to inlineable method? Okay. So this is good. This is good. We can actually map from this name to something in defs. I don't know why they wouldn't just stick an object here, right? That's so crazy to me. I don't know why they wouldn't. And again, it's still problematic because like you could always just have another thing called inlineable method, right? So okay, but here's the thing: is it has a pose. Well, anyway, okay, whatever. Let's just. I think it kind of does sort of make sense because in this particular case, we don't care. We know we're at the right spot in a sense. So if we write down this exact instance of ast.ident, then later, assuming the links in the library were done right, then it will always point back to this particular one if it is in fact calling this particular one. So I think we're good. What we basically do is in our gcassert file, instead of writing down n.obj like this, what we actually do is we sort of say v.must inline funcs of v.p.typesinfo. Defs of n.name. This is our true thing, and we should probably capture this and make sure that it's not nil first of all. So if obj is not equal to nil, we hit this up. Okay, I think that this might no good, unhappy. Why? What does this give me back? It's an object. I need a wait. What? Wait. Don't tell me it's like a no. It's a types.object. What the hell? The other thing was an ast.object, and this thing is a types.object? Dude, no. Okay, I don't know. I'm just not gonna think about it. What if I don't ever care about ast.object ever again? And I need to be looking at types.object. Maybe that'll be fine. Oh, it's so gross. It's truly, really horrifying. And then in this case, what we do yo, this is bullshit. How can this be? How can this be? How can this be? It's horrifying. I'm lost. What is the difference between a types.object and an ast.object? And why is anything the way it is? Okay, let's go back to our types info. I like types info. Types info, like in a sense, it sort of does have what we need, right? It's got our selections, it's got our defs, and then we probably want to use this, uses. Let's just assume that that's what we want, okay? Let's just assume that that's what we want. All right, so we'll say obj is equal to v.p.typesinfo.uses.n.n, just n. If obj is not equal to nil, or if it's equal to nil, then let's just leave. Okay, let's just hope. Let's just cross our fingers, all right? We're crossing our fingers. We're crossing our fingers. Wait, we have to recompile this. We're crossing our fingers. We're gonna see if everything just completely explodes. Nothing exploded, but nothing really worked either. Okay, let's go back to the debugger. That's not surprising. It's not that surprising. Not that surprising. What do we have in our debugger? It's when we're looking at selector exprs. Let's restart that. Let's just jump over to here. So this is when we see a call expr, we're going to see if anything is in fact inside of this types info uses thing or not, you know? So let's see, n right now is this inlineable guy. This is a call expr, so it's gotta be inlineable. It's gotta be this, right? Probably. Call expr. The fun is inlineable. The args is Int, wrong file. Get out of here. Get out of here. Yeah. I should really just make this run on one file at a time. Now we're calling something called always inlined. Here we go. Okay, so now we're back to where we want it to be. And here's the dream. Do we have an obj or not? We do have an obj. And the obj is something called always inline. Okay, so this is good. This is good. This is good. And let's see if there's anything inside of must inline funcs, which there certainly should be, because we have something over here for it. And there is. Hey, that's pretty good. That's pretty good. I'm feeling good about this then. Send. I think we're really close. I think we're close at this point then. Right? We've got to be close. We've got to be close. We don't see a call to always inlined, right? So that's good. Oh, I see the issue. It's this dumb old thing where I forget to reassign the struct back to the map. This is very good. Very, very good. Okay. So the next thing that we would just need to do is make sure that it works for the selectors. And then I think we're going to be in business. Get rid of this stuff. We're going to say, really we want to have this be the same in both cases. And we want to pull out the obj. So we'll say var obj types dot object. We'll get the obj in both cases. And we're going to say obj equals cell dot obj. Maybe. Is that right? Yeah, that is right. Okay. Is it gonna work? Is it gonna work? Is it gonna work? Yes. Oh my God. This is literally the dream. I don't know how it happened, but I think I figured it out. Always inline, not inline. Always inline, not inline. Okay, here's the only thing. Is that I'm confused. Okay, so for inline.go, line 44, the complaint is that this was not inlined, which is good because I've marked it as not inlined. So that's the dream. 50. This is marked. This is a fail. This is a pre-existing test case. 52. Always inline divide, not inlined, even though it should be, right? We don't need this because we already are testing it. So we can get rid of that test case completely. And then the question is these last three ones. Let's actually run it one more time. So for lines 56, 57, and 58, we only see something for this last one, 58. Never inline method call was not inlined. Because this guy is... This is an unnecessary test case for sure, because we don't care about it at all. It doesn't have anything on its annotations. And I think what we want to do is mark this guy as gcassert inline to make sure that it fails. And this is going to be hopefully our actual test case that we care about. So line 54, we see a fail. Never inline method call was not inlined, which is the dream, and always No fail here. Hey, I think I got it to work. I think I got it to work, you guys. Hell yeah. Yeah, dude. Well, I don't even know. I think we're done. It was really painful, but I think we're done. Let's make a commit. It feels a little bit anticlimactic now for some reason, but I think I've actually learned quite a lot. Let's make some comments. Must inline funcs or whatever. So must inline funcs is a map from types.object, which is essentially, I don't know, from types.object that represents a func expr of some kind. I guess it's a func decal. It's really a set of types.objects that represent func decals of some kind that were marked with gcassert inline by the user. And this is actually much more powerful than it was before, because we don't have to care about line numbers. I mean, well, we actually do still have to care about line numbers because the whole point is that the compiler outputs line numbers. But hey, I'm actually very excited about this because I think it might be useful in my other project, the execgen project, which needs a lot more complex analyses. And having this sort of information actually would really help. So I'm getting pretty pumped about this. Now that I figured it all out. Search for all func call sites and write down the line numbers. Okay, so here this is sort of like, yeah, we just need to change this. Not write down their line numbers, but func call sites of functions that were marked with gcassert inline, and add inline directives to those call sites. Basically that. Okay. Let's see. So I guess there's sort of two commits here actually. One is a bug fix. And I should probably change a test case just to make sure that bug fix still is all good. Oh, we already do have a test case for this. Essentially, like my regex was slightly broken or something like that. The regex wasn't, but the loop around it was. So let me make a commit for that first. So I'll say git add -p, let's try that again. Okay, so we need to just search for where I changed the loop here. So it's this, basically just that on its own. gcassert, don't fail, or like bug fix for decals that had long comments. Had other comments. To comment parser. Previously, functions that had block comments that contained more than just the gcassert directive didn't get their directives parsed properly. Let's actually just quick run all of our tests because I didn't. Oh right. I don't know why it's a. Why would this? No. I forgot that there's a parsing test as well as just an actual output test. Okay. What does this test do again? gcassert test. Oh, I know what the problem is. It's because I didn't ask for all of the type info stuff. I need to say also include packages dot type need types and packages dot need types info. Okay, so I think hopefully that will fix. I think the test will still be broken. because I didn't edit it, but at least it won't panic anymore. Right. Okay, so the new tests, I mean, this is kind of dumb, I guess, but it's good to have these. It's good to have these. So the new tests have a bunch more directives inside of the inline file. It's one on line 19, right? This is really dumb. I just don't know of a better way to do it though, without doing like a fancy test parser and stuff like that, which I don't really need to do or care about right now. 24, 36, 41, 45. $47, $51, and then $53 and $54. This is so stupid. Oh man. Just hold your nose and close your eyes, as they say in the hit musical Hamilton. Okay, try this again. Okay. Okay, so what is this saying? How come there aren't line numbers in these? This one I understand why it failed, because I haven't added the actual... Maybe this whole parse test is really pointless though? Like, I don't know, dude. Is it really pointless? Oh, you know, I think it's actually gonna be... I think it's actually telling me something that I did wrong. So maybe not so useless. I think it's telling me that I've added some things to the parse map with no directives, and I think I know why that would be. I think it's because probably if I see a function, I don't like not delete this thing or something like that, you know? It's like, it's found a node that has 0 assert directives, which should never really happen. I should only really add stuff that have non-zero numbers of... Is it this? Is this the problem? It's really hard for me to say because for some reason this printer doesn't give me the line numbers, which is really frustrating. I guess if I search for gcassert.assert directive and then nothing, that doesn't give me anything. What if I search for directives nil? No? Okay, here's one. So this is line 24. Has no assert directive. So what is line 24 exactly of this test case? It's this func. So why doesn't this one have directives? Does that not make any sense? I guess it doesn't, it's not really necessary for it to have directives because the whole point is that I'm never going to be looking at that output. So yeah. Yeah, the issue is here. So if instead of doing continue, and I basically just want to like leave this whole situation and not do this case here, which means I sort of need to say, I sort of need one of those like big breaks again. So I'll just make another one of these comment lists. So I'll say break or continue comment list. I think that'll fix my test case. I'm hoping. I guess the difference is that I also don't really want anything in line 24 and line 19 because those are these func decals that I don't care about saving in my map. Same with line 36, actually. Okay, so maybe this will now pass the parse test. Great. So we passed the parse test, and now we just need to make sure that this thing passes, and we've already verified this output is correct. So I'm just going to paste it in, basically. Like so. And get rid of this stuff, and then let's run again. I think this should all work. Then I think we could be done. No. Oh, is it like non-deterministically in and out of order for some terribly stupid reason? Oh yeah, I was afraid of this actually. I think like we're using some maps, and in Go, like they randomize the map iteration order and stuff like that. I don't care, I'm just gonna sort it. Or should I sort it? Yeah, it's just gonna be annoying. If I sort it before actually outputting it, the sort's gonna be gross because it doesn't know that these are numbers, and it's gonna sort by like, you know, lexicographic number ordering, which really is terribly gross. So I think what I'll just do is, nah, man. I did want to sort of figure out why this stuff wasn't sorting properly. This is just going on and on though. So let's see. Where do we iterate over that map? Where does that happen? Where does that happen? It's here for each of the things in directive map. This is where we get into bad trouble. And a directive map is this big map of maps. Ah! I mean, I suppose I could just sort the keys and then iterate over in that order, something like that. Ah, it's just too annoying. I wish that there was like a sorted map thing in Go, like just a quick shortcut, because sometimes you just want that, you know? Go iterate over map sorted. Is there like a... Yeah, you gotta collect all the keys, sort them first. Oh, it's just so annoying. Like, why do they make you do this? I'm just gonna sort the test output for now, because I'm fed up. But even doing that's kind of annoying, to be honest. Like, you have to split it by strings, by lines too. No, I'll just do it right. I'm gonna just very quickly do it right. Okay, so here's what we're gonna do. So we're gonna say keys is equal to make string len directive map for k in range directive map keys. I guess I also need the, wait a minute, I guess I need 0 keys equals append keys k, and then I say sort dot strings of keys, and then I say for k in range keys. Then I can say line to directives is equal to directive map of k. And then I'm going to be sorting that one in order, but then I think this next guy's going to be out of order, right? So that's also irritating. So I'll also have to sort this next map. Again, obnoxious. So I'll say, now what is this again? Directive map is it's a map from int to line info. Well, I guess that's good. Okay, so we'll just make lines is equal to make int 0 len line to directives for line in range line to directives. Lines is equal to append lines line. Sort dot ints lines. Then I can say for line in underscore line in range lines. Then I say info is equal to line to directives of line. Okay, now I think it will hopefully output in deterministic order. Way later. And I think it'll still fail, but at least I'll be able to copy that output and it'll never change after that. And on the plus side, it'll also actually be sorted, which I think, so this is gonna be a net win for us. Even though it was mildly annoying to do, I think it was worth it. Will be sorted now. Baller. We could optimize this a little bit because we don't need to remake this. We don't need to remake this lines array every time. So let's just quickly do that too. It's super premature optimization, but hey. Var lines int. Lines equals lines of 0. All right. Totally worth it to optimize those allocations. For real. Okay, cool. So we can maybe now commit this. 1, 2, 3. Git commit. We'll say gcassert. Guess we don't need that prefix in this case. We just have one package. It'll just be like inline can mark functions methods with gcassert inline. Marking a function with gcassert inline will now assert that every call site of that function is actually inlined. I guess I sort of need a README entry for this as well. Func add one always inlined int gcassert inline. Add to ints of I gcassert BCE.
Database.
Yo, TuxKey21, thank you for the follow. A gcassert inline directive on a function will cause gcassert to fail if any of the callers of that function do not get inlined. Then down here I need to say on a call expr, the
computer's hooked into over 1,000 data banks throughout the world.
Yo, Nate Lift 151, thank you so much for the follow. On a func decal asserts that every caller of that function will actually I guess I'll say is actually inlined by the compiler. All right, then we can say git add one. We'll say update readme with info for gcassert inline on funcs and decals. That has a misspelling. Decals. Let's just make sure that this is still like building and everything. Seems like it's pretty good to go, honestly. So we can push this. And maybe we can actually just take a look at the repo. So if you care to follow along, or if you want to check out how this thing is working, you can check out the repo, which is over here. So it's this gcassert repo. Feel free to use it if you're a Go programmer. I think it's a pretty handy tool. Hopefully I'll keep making this thing better over time as well. And I think, yeah, I think that's pretty much it for tonight. So thanks for bearing with that earlier part where we were a little bit intimidated by that types info package. I think we learned a lot. I think I'm pretty excited about the promise of this types info stuff. It's actually a lot easier to use than just AST manipulation itself. So hopefully we can reuse this stuff again. But anyway, thanks a lot for hanging out with me tonight. It was a lot of fun. I appreciate all the help, by the way. I feel like this was a good example of y'all being helpful, which was awesome. I had a lot of fun. I hope you had fun too. I think we're gonna raid my favorite Mario streamer, The Wild Grim. So if you are around, just, you know, check this out. I think it's a lot of fun to hang out with this guy. Pretty friendly, good at Mario. But until then, you know, it's been a lot of fun. I will be back next Friday. So tune in, follow me if you haven't, and I'll see you then. See ya.
Jen told me to get a fucking I emoji.